In this video, I'll be doing the maths question you see on the screen here from paper 2 of the 2024 Maths Leaving Cert exam. If you're looking for a different question from this paper, check out the playlist in the comments below. I'll be doing all this on a whiteboard, hopefully like you're used to your teacher doing. But remember, you're not in a classroom here, we're on YouTube, so take advantage of that. Pause, rewind, watch a half speed or watch a 2x speed. If you do find these videos useful, or any of my videos, I would greatly appreciate a like or subscribe, but especially I'd appreciate you sharing it with a friend doing the Leaving Cert or doing it next year. Question 7, they tell us a story about a hotel chain in Europe, and in part A they ask us, well, they give us a couple of bits of information first. They tell us the average age of the person in the hotel is 48.2 and the standard deviation is 10.6 and it's normally distributed. Now you don't have to draw a picture for this question, but honestly in maths, if you can draw a picture, do. Don't waste too much time, but draw a normal distribution. Helps you think about things. This normal distribution is 48.2 is the mean, so that's the center there, and has a standard deviation. So some standard deviation away is 10.6. It's the standard deviation away. And the question they ask us here is, they say one person has picked at random who stayed there. Find the probability that this person is less than 50 years old. So the probability that they are less than 50 years old. 50 years old is about here. Go up here. So really, I want to find out what's the probability they're in this world. Everything to the right. Let me draw it again. There's the middle. Here's 50 years old. I want to find out the probability they're in this part of the world. And this is a very famous question. It's very common. There's your tables has a whole section on it to help you work out this sort of thing. Probability. It really gets more difficult when they ask you about something that's on the left of it. You have to do a little thinking, which I think comes up later in this question. Anyway, from this point, what we need to do is just find this point there, this 50 point in its Z score. The Z score of this point. That sounds very confusing. I know you've done it before, but it sounds a little confusing. So forget about Z score. What you really need to do is find out how far away from the middle it is in terms of standard deviation. So basically the middle is 48.2 and we're at 50. How far from the middle it is. That's what the Z score is. It's 50 minus 48.2. How far from the middle. And then we divide that by the standard deviation. And that just tells us how many standard deviations away. So on the top here we get, just double check here, 1.8, the bottom 10.6. So we're 1.8 years away from the middle. But how many standard deviations? Is it one standard deviation? That'd be 10.6. Is it half of it? Is it a quarter, a fifth, an eighth? It's just divide that in and we get, 0.1698. That's it. That's the Z score. Our tables book where we're going to look it up only deal in 2 decimal places, so 1.7. Yeah, hopefully that was clear what I'm doing here with the Z score. There is, let me draw the tables again. There's a Z score of 0 here. 1, that's 1 standard deviation away. 2, 3, even minus 1, minus 2, and so on. Where we were interested in 50. 50 was just a little off to the side here. That's where I got 0.17. And if you have your Z, you can just look up in your tables here. Am I on the right page? Yeah, in your tables here, you can just look up the number 0.17. You do that, you go by 0.1, you find here, you go across this 0.07, add that on, so it's 0.1 plus 0.07. Well, you say don't add it on, the number to give you here is the work done. You can do this without the tables. If you have a fancy calculator, you can do it, or if you're really good at maths, there's a formula given in the book that you have to integrate this very difficult sum. You can work it out yourself. But the reason tables exist is it's very difficult to do yourself, and they didn't used to have good calculators. So if you put that in, you get a probability. Again, the probability of the book there. You put in your z-score and it gives out the answer of, let me see, 0.5675. But they asked, I think they asked for percentage. Find the probability. No, just ask for the probability. So that's fine. Again, if you want to put it into percentages, you shouldn't. They said probability, you should have left it like that. But that is that in percentage. You won't lose a mark for that. Okay, let me clean off some of this and we'll do part 2. Now for part 2, they say exactly 10% of people who stayed in the hotel in 2023 were at least A years old. So some number, A, an unknown number. Find that value. It's the opposite to this question we just did here. They're saying exactly 10% of the people. They're saying this number of people were a certain age. What is that age? You know what? I've just made the same mistake I made when I was doing this question on a piece of paper before. This is not what they say. The English is difficult here. Exactly 10% of people who stayed in the hotel are at least A years old. So put a number on that. Are at least 10 years old. Exactly 10% of people are 10 years old. At least 10 years old. I'm at least 10 years old. I'm 40. So no, that's wrong. That's wrong. 10 years old won't be the right answer. Try it again. At least 10% of people are at least 70 years old. Yeah, okay, that might be a smaller number. So we're looking for 70, somewhere up on the right here. So we're going to actually, I'll have to clear this board off and do it again. We're actually going to have to look for 90% over here. And we're going to have to find the 10% on this side. So let me clear the board off and we'll start this again. Okay, so remember what we have. We have a normal distribution of people. The middle age is 48.2. They want to know what age you would be for 10% to be at least that age. So the mistake I made earlier was thinking it was 10% was down here, but it's actually the 10% up this side here who would fit that category. So we're going to have to look for 90% of people. So how do you do that? You go to your tables book again and you find where 90% is. You find 0.900 if you can. You will not find that. The closest you'll find in your tables book is 0.8997, and that will be at a z-score of 1.28. So the z-score of here 1.28 is where our answer is going to be. It's where 10% of people would be over here. So that's what you have to do there. It's very common to have this type of question, basically asking you to answer it backwards from the z-score. So now you have your z-score. Remember how we got z? Well, you don't actually need to use the formula. Remember what this is, the z-score. It's 1.28 standard deviations. What was the standard deviation? 10.6. 1.28 of these to the right. That's one way to think of it. So 1.28 multiplied by 10.6 is equal to 13.568. So the answer would be 13.568 away from here. So we get 48.2 plus 13. We don't need all these decimal places, but still. Add them together and we get 61.768, but they only wanted to the nearest whole number, which is 62. So just double checking that question again. Let's read the English out. Exactly 10% of people who stayed in the hotel are at least 62 years of age. That makes sense. Only 10% of people would be over 62. So I'm really sorry, the English there was quite difficult. At least I'm guessing if you had got the other side, if you'd done the question like this, you would have got the same number here, you would have just ended up taking it away from there. And I did do that out just so you'd know. You would have got an answer of 35. So that means 10% of people were under 35. 10% of people were over 62. I do think it was very confusing what they were asking, but that is the actual answer. I'm guessing you would have got most of the marks if you gave 35 as your answer. Okay, on to part B. They simply tell us that 1/5 of all customers use the pool. They say 6 customers are picked at random. Find the probability that exactly 2 of them use the pool. There's a couple of ways to think of this question. I'll think of it like this. Let's just draw 6 people. I'll draw them as dots. 6 people here. What's the probability that the first person used the pool? It's 1/5. They used it. And we need 2 of these to use it. Second person, I want them to use it as well. And then 2, I only want 2 to use it. So the next person has to not use the pool. 4/5. I guess I should have said that first. Use the pool is 1/5. They told us that. That means not using the pool is 1 minus that, 4/5. I want this person not to use the pool, this person not to use the pool, and this person not to use the pool. For all that to happen, the chances of all that happening are, multiply them together. That's 1/5 squared. Multiplied by 4/5 to the power of 4. And whatever the calculator would tell you that is. That's the chances of this happening. Of the first person I pick out using the pool, the second person using the pool, the third person not, the fourth not, the fifth and the sixth not using the pool. That's not what they asked though. They didn't ask the chances the first and second person I picked used the pool. They asked exactly 2 of them. So instead of this, use, not, it could have been use, not, not. There's lots of other ways I could have arranged this. And each one of them is possible. It could be this, or it could be a different way, or a different way. So I have to count up how many different ways there are. So we have a formula to do that, don't we? It's how many ways there are to choose 2 from 6. That's 6, choose 2. You can do that in a calculator. You can do it out yourself by hand if you want. I think, do I have the number there? No, I don't. I think 6 choose 2 is 15. I'm not 100% sure on that. So you could do that by hand. There's this way, this way, this way, and so on, and just stay counting all the way down. Yeah, shouldn't be too big of a number. Once you get it though, put that in the calculator. Well, let me just go over what I said there. So this is the probability of 2 people out of 6 doing this in an exact order. But there's 6 choose 2, or 15 I believe, different ways I could have arranged that. Putting all that together gets you the answer to the question, and that's 768 divided by 3125, or in decimal form, I'm not sure if they asked for that, as 0.2524576. Anyway, that's B part 1. For part 2, they say n of the customers are picked at random. The probability that none of them use the pool. Now this is going to be easier because none of them using the pool doesn't matter the order, because they all have to not use the pool. So how do I do this? Let's imagine we just picked one person. One person picked out. What's the chances of them not using the pool? Well, not the pool was 4/5. What about if I pick 2 people? What's the chances of both of them not using the pool? It's 4/5 times 4/5. And it doesn't matter how you arrange that. They're all not doing it. And again, or you could write this as 4/5 squared. As they say, it goes on in this pattern. So there's some number n amount of people, and that's just 4/5 to the power of n. And they tell us the problem. They tell us the answer. They tell us that equals 0.0047. Yeah, that's correct. Basically now we just find what n is. So just solve the algebra. Now it's not an easy one to solve. We have to use logarithmics. So it's not that hard. It's very short in a calculator. Logarithms. I can't pronounce it, but you probably know what I mean. So how do we solve this? We just need to cancel the 4 over 3. Divide both sides? No, that doesn't work. Take away doesn't work. To invert power? No, it doesn't work. How do we get rid of 4 over 5 on the bottom row here? We get the natural log of 4 over 5. Again, 4 over 5 is just 0.8. That will cancel that and will just leave us n. But if we do that on the left, we have to do that on the right. So natural log 4 over 5, 0.0047. N is left here. Yeah, just an n left equals this. So n equals, put that all in a calculator, and they want it to the nearest, nearest whole number. We're talking about people here. Can't have half a person. The answer comes out as 24.0212, so on and so on. 24 is the nearest answer to that. And you can double check that by putting it in here. 4 over 5 to the power of 24 should equal roughly that. You'll have to round it. There'll be an extra few digits here and there though, because we rounded off up there. Okay, on to part C. They tell us quite a long story, but basically they have a new website. They have an old website and a new website, and they decide at random to send people to one or the other. And I'm going to start drawing this as a picture. Everyone that starts comes into the website here, and 45% of people go that way to the old system, I believe. Yes, the old system go that way. The new system go this way. At that point, they tell us that 1/3 of the people using the old system, everyone that got here, 1/3 of them booked. Actually, let's put 1/3 over this side. They booked, and that means 2/3 didn't book. They didn't book. They're going to disappear for us. We'll still draw them in. 1/3 of them did book. Now, the people who use the new system, they also tell us 2 things happened. We'll put the 2 booked ones here in the middle, or maybe that's confusing. So let's say not booked, booked, not booked, booked, new, and old. Okay, so what happened? The new website, 2/5 of people, 2/5 of people booked the room. So 2/5 here, and that means 3/5 didn't book a room. So they're just going to ask us basically a question about all of this. One person is selected at random from those that booked a room. What's the probability they use the new system? So that's what they're asking here. What I think is helpful here is just find out the probability of getting to each of these ends. So you start here, you go a probability of 0.45. You could change this into 0.6666. Either way, put this in a calculator, multiply that by that, will get you the probability of being at the end here, which is, I wrote mine in a different order unfortunately, gets you the probability of 0.3 to get there. Do the same here, 0.45, that's the chances of you using the old system. And then once you're on the old system, the chances of booking are this, multiply the 2 together, and you get 0.15. Again, chances using the new system and not booking are 0.33, and again the chance of using the new system and booking is 0.22. Let's double check all this adds up to 100, because there's no room for anything else there. You either booked or didn't book. You either used the new or the old system. So they do here. This adds up to 55, which you would hope as well. And these two add up to 45. 45 and 55 adds up to 100. At this point, you could make up a number if you wanted, just to help you think about it. And it will actually help in the next section. You don't have to. I'll do it both ways. At this point, you could say 100 people went to the website. Just 100 people started. that would mean 30 people used the old system and didn't book. 15 people used the old system and booked. 33 people used the new system and didn't book, and 22 people used the new system and booked. That does help lots of students think about it. You don't have to use this. I'll do the next part 2 different ways just to show you it doesn't matter. So the actual question is, one person's picked at random. What's the chances that they use the new system? So remember, they never asked these people here. They didn't ask these people. They were gone. They went to the website and then left. We have no idea about these 2 groups of people, this 30 and this 33 people. We've no idea about them. They only asked these people that booked. So when we're working out probability, the total population is just 0.15 plus 0.22, or if you want, and yeah, I'll do it again down here, 15 and 22. Or if you made up 1,000 as a number, that would work fine as well. So when they're asking us what's the probability, we have to divide by the total. Well, the total here isn't 1, it isn't 100, it's only the people that booked. So the total is 0.15 plus 0.22, which is, I guess, 0.37. Or an easier way to think of it is they only looked at these 37 people. And then they asked us, what's the probability they use the new system? Well, these people here used the new system. These people didn't. So only 0.22% of the people, or probability of the people, use that system. 0.22. Or if you were making up your 100 as a number, 22 out of 37 use this. So what's the probability? Just put that in a calculator. They both give the same answer. To the nearest percentage, 59%. Or indeed it would show up as 0.59. Both are fine. Okay, that answers part C. Let's do part D. Okay, part D is a hypothesis. I can't pronounce it. Hypotenuse test question, which honestly I'm bad at, because you have to learn just how to do it, how to write what they want. And then within the question is sort of a stats question, which I don't like either, which I'll explain why. But anyway, they give us 2 bits of information here. So they say in 2020, this hotel chain had a 75% customer satisfaction, something like that. Yeah, rated 75% by their customers. They don't tell us how many they asked, so we'll assume that's a perfect number. 75% is the exact number of people who like this company. Now in 2024, well, let me write up 75 or 0.75. In 2024, they carried out a survey of, so that was in 2020. In 2024, they asked 1,000 people, do you like the company? And 765 said yeah. Straight away we can just say 0.765 was that favourability. But then they want you to carry out a hypotenuse test at a 5% level of significance, and that shows, let's say, this shows a chain, to see if it shows a change in percentages. So have they changed? It was 75, now it's 76.5. Has it changed? Again, you see this in newspapers all the time. Oh, the number has changed. Whereas what we're trying to show you here is sometimes it hasn't. Like straight away, without even doing the question, I'd say these are way too close to each other. Definitely I'm not confident that has changed, because this has been asked over 1,000 people. So, well, this is jumping into the question. This is not the correct number here. 0.765 is not the correct number. The correct number is 0.765 plus or minus something. So plus or minus something, and we'll decide that because of this 1,000 number here. Now, I never liked this sampling testing thing. One, I didn't do much statistics myself in college, so I don't fully understand it that great. But what I did do, I was a lot different than what we teach in the Leaving Cert, so that's another reason I don't like it. It's quite simplified. So what we teach in the Leaving Cert is simply this: for a 5% level or a 95% level of confidence is plus or minus 1 over the square root of the population, which is 1,000. We'll work that out in a moment. Back to what they want you to do for the hypotenuse test. They want you to fill out a few sections here. Null, hypotenuse. I know I'm pronouncing that wrong, by the way, I apologise. They want you to write something there. They basically want you to write the opposite of what the question is. The question is, has the probability changed? Has the percentage changed? So the null would be, the probability has stayed the same. You can write something like the new customer favorability is 0.75. It stayed the same. It hasn't changed. Any sort of language like that. The alternate hypotenuse, that's basically what they already gave you. They said it's changed. It's the probability is not 0.75. It's changed from that. So maybe it has. And then we're just gonna answer, which is it? Has it changed? Has it not changed? They ask you to fill out a section of calculations. That'd be this. Let me write this again. That's plus or minus. What's this? This is 0.03162. Or really, instead of plus or minus, let's take this away from that and we'll get 0. So this minus this, we'll get 0.733. I've rounded off there. Or if we added onto it, we would get 0.797. So that question they asked, 1,000 people, 765 of them said they like this. I think it's like or not dislike. Like this hotel. It looks like 76.5%, but it's not really. It's something in between this and this. So somewhere between 73% and 80%. That's all we can say from that. So the question was, has it changed? I don't know, because 75 is in there, or 0.75. It's in there. So for all we know, any number between these two is the 2024 number. We know the 2020 number was 0.75. For all we know, it hasn't changed. So that's your answer there. We can't be confident that it's changed, and they want a reason, and that's because 0.75 is in this range here. I won't write any of that down because I don't fully know what technically to write. I'm terrible at this. You shouldn't listen to me. Find another video online that answers these questions. I'm bad at them. I think everything I said is technically fine, and maybe it's helped you. Anyway, that's it for this entire question. Thanks for watching. Let me know in the comments if there is something wrong or something you want me to try and clarify. Really, statistics is not my favourite topic. Thanks for watching. Have a good day.